Welcome back to the demo studio. My name is Nick. Today we're going to be going over most of the general features of the Pro 2. I'll go ahead and get into the features overview of the Pro 2 Plus. The standard size build volume on the normal Pro 2 is 305 millimeters in X, Y, and Z, or roughly 12 by 12 by 12 inches. Pro 2 Plus, on the other hand, is the same base build volume for the plate, 305 millimeters by 305 millimeters. Now, both machines run full touchscreen displays, and these displays are broken down into 4 submenus. Initially here on the home screen, when it is running a print job, it'll show a preview, parts the machine is running. It will also display the estimated time remaining, the height and specific layer that it's running, the percentage of how much it's already completed, and the file name. And then from this screen, I can actually also set the temperatures for both nozzles and the heated bed if I need to preheat for any reason. There is also another feature that isn't used too often that I think adds a lot of usability to this. And it's in the upper right-hand corner. That kind of cluster of 4 squares will get you into the quick settings for this. In here, this is where you would connect to cloud and receive jobs from cloud if it was connected. But up in the top here, you also have the options to add a template for the preheating temperatures. So from here, I can go ahead and add in a new template. And then I can set the temperatures for both nozzles and the heat bed. So when I save that, I can go ahead and just select this preheat template, set it to preheat, and then it will set all the temperatures and start heating up from there. So it's a much faster way to just get these going rather than having to go back in and type all the temperature settings. Moving on to the tune screen, this one has the same 3 heating options as well as the feed rate, which will actually control the overall print speed, fan speeds for cooling, and then left and right nozzle flow rates can be adjusted individually. These are mostly used for fine-tuning materials and adjusting flow when you're testing new parts. All of the flow settings are also handled in IdeaMaker in the templates. On utilities, this has all the options for homing and operating all the axes. This is also where we manually shift the extruders. So if the extruders are set to 180, then it will allow me to manually shift them. Otherwise, it will automatically shift them while it's printing if it's running a dual print. The way that we do that manual shift is keep them both to 180, and then I can select either the left or right extruder. Whichever one is selected is the one that I will be engaging and bringing down. So I can go over to the print head in a second. When I go up to that, I'm going to hit the right nozzle, hit the down arrow, and then it will shift down. Same thing if I switch back, we can highlight the other hot end, hit the down arrow, and then that one will switch. On the utilities, also you have the options for loading and unloading the left and right extruders. Basically just typing the temperatures there and then hitting load will start the sequence for loading the machine. And then lastly, from the print screen. From here is where we access files for the local storage. We can either connect the machine to a local network via Ethernet or wireless and then push G-codes directly to this display through IdeaMaker, or plug a USB drive into the side of the touchscreen. From there, I'll pull the G-codes off of that, just going through the display and finding the file and starting it that way. In the print screen, there's also the option for managing the upload queue. That would be just to see what's being uploaded through IdeaMaker. Options in here for running a temp task, and then most importantly, the dashboard. Dashboard holds all of the history of the machine for every part that has been run. This is also where you would find time lapses or any images that have been taken of these. And then for local storage files, I can actually start a new print directly from the dashboard as long as they are, again, already on the machine. Moving on to the print head itself. I already went over the nozzle assemblies here. Currently, right now, this machine is running 0.4 millimeter brass nozzles. We do also have nickel-plated brass nozzles that go down to 0.2 millimeters diameter and up to 1 millimeter diameter. And then we also have the newest hardened steel nozzles with a ceramic coating. Those will go down to a 0.4 and then up to a 0.8 millimeter. So if you wanted to have more abrasion-resistant nozzles, you can go into the tool steel ones over the nickel-plated brass. Looking at the rest of the print head, further up, we are running a direct drive extruder. So we have this motor on the front for operating the left extruder. There's another one on the back for the right side. And then at the top of this print head, there's an optical filament runout sensor. So at the very top of this, if the filament ever runs out, that light's going to come back on. It'll then automatically pause the print, go back into its home position. You can then actually just feed it straight back in and load more material once that is caught in the extruder gears. It's good to just continue printing, so you can resume it from here. It basically works the same as the power loss recovery also. So if the machine ever loses power in the middle of a print, when you turn it back on, it does know that it was a power failure. So it will just prompt from the touchscreen whether or not you would like to continue, restart, or start a new job. Hitting continue will just heat it right back up to the temperature it's supposed to go to, and then send it right back into the G-code sequence. And then on the bed surface itself, it is a removable plate. It is a rigid plate. The Pro2s have a rigid plate over the E2's flex plate. But for this one, it is aircraft grade aluminum, so you get a really even heat distribution across the entire surface. On top of this, we are running a polycarbonate blend for the surface itself. All your standard materials will stick to this really well with no additives. So PLA, ABS, PETG, and TPU print directly on the surface. If you are going into higher grade or more exotic materials like polycarbonates and nylons, then for polycarbonate material, we actually recommend a few layers of PVA glue stick to act more as a separation layer between the material and the surface, because it's a PC blend. So you do run the risk of it bonding to the actual surface. More so with third-party materials. The Raise3D branded materials don't stick as strongly to this. So that's a plus. But the surface can get worn down over time. So if you do notice a more consistent loss of adhesion, and then adjusting the Z offset, the height between the nozzle and the bed when printing, if that doesn't increase the adhesion, then you can actually peel off the upper surface and then lay down a new one to reapply the adhesion. On the right side of the machine, this entire side door opens up. That'll let you load in your 2 filament spools. It'll hold 1 kilogram spools just fine. If you did want to use larger size spools like 3 or 5, then for those larger spools, if they are lower temperature materials like PLA and TPU, then it's actually best to mount them above the machine on another holder and feed them directly into the top of the print head. For higher temperature materials in those larger spool sizes, you will need the lid on top of the machine to maintain that higher ambient temperature to prevent those materials from warping. In this configuration, if you are using larger size spools, then you can actually go ahead and feed them through the gaskets into the side door. That way you can still get them up to the print head, but maintain the full enclosure. And then lastly, on the back, there is a Hepa filter included in the enclosure that's going to filter out any fumes or particulates that are given off by certain materials, most namely ABS. So if you're working with ABS exclusively, we recommend replacing this filter every 6 months. Otherwise, for materials that don't need to be filtered, you can switch it out closer to a year or a year and a half. Remember how we get into here. It is going to be in the main settings of the machine. Then we're going to want to get into more settings and then privacy and security. While we're in the privacy and security settings, this also has the options to enable the screen lock or a password that can also be run through a DMaker. So if you did want to put protections on the machine to keep other users out, you can put a passcode lock on the touchscreen, and then only the person who has the passcode would be able to use any of the features through it. This does also have on the next page, enable time-lapse export. So you need to have that enabled. And then once that's enabled, back in the dashboard, this has the time lapses. Then when that's enabled, you have another option to export, and then that'll just export the time lapse to the USB drive. Let's see, with certain patents ending, I have not heard of any more additions going to be coming up to the Pro2 series. We also did have the E2, which is an IDEX machine, so more than likely the E2 is going to be our IDEX for the time being. We currently do not offer a Ruby nozzle. I know the Olufsen Ruby is kind of runs into the same problem that some other third-party nozzles will with our machines. The way that our nozzles are manufactured is they are actually chamfered inside, so they seat up against the throat tube that is, again, machined to match. So there's a better seal fit there because it seats into the nozzle. Typically, third-party manufacturers will cut the nozzles flat with these hot-end assemblies that can increase the risk of it leaking. So that's why we typically don't recommend running third-party nozzles vis-a-vis the Ruby on these machines. There is, I believe, another version of a Solex nozzle that I'm kind of familiar with, but again, that one's a bit more third party. But for the time being, I would definitely recommend the hardened tool steel nozzle that we offer as the best abrasion resistant nozzles for the Pro Series. So getting into the leveling process. It is done manually with a 0.2mm feeler gauge or feeler card that I have here. The main process for it is done by adjusting the Z offset pin in the left corner of the bed. What I will be adjusting in order to increase or decrease the gap is going to be this assembly on the side. Kind of looking at that. This lower pin down here, if I turn this towards the back of the machine, it'll raise this pin and lower the bed. That increases the gap between the nozzle and the platform. If I turn it towards the front, that will lower this tab, thereby raising the bed up and decreasing the distance between the nozzle and the platform. So to run through a quick Z offset check, I'll go ahead and home the bed. And then once it gets to its home position, I'll go ahead and check it with the feeler gauge and then make any adjustments as needed. In its current mode, when it goes up to home Z, it will go at a faster speed until it hits the sensor, then drop down and very slowly raise itself back up. I'll actually, rather than watching the bed, keep an eye on the Z lead screws. So when these stop rotating, that is a clear indication that the bed has stopped moving and it's now in its home position. So with the left or right nozzle lowered, whichever one you want to check for the Z offset, you do need to have that one in the current lowered state, just using the same instructions that I went over for the utility screen earlier. Go ahead and take our feeler card. I want to run it underneath the nozzle and just make sure that it is close enough to where it makes contact and I can feel it touching that feeler card, but not so much that it has that it's difficult to slide underneath here, or that it is too close that it prevents me from getting underneath the nozzle. And then if it is too far away, I can go ahead and again turn this towards the front of the machine. That will bring the bed closer. If it is too close, I'll rotate this and push it towards the back. That will then lower it. And again, I will adjust the pin and then rehome Z between every adjustment. It needs to basically find the new Z position after I've made the adjustment and then go from there. So that's for the Z offset. Leveling on the Pro 2s typically does not need to be adjusted. It most often is an issue with the Z offset, or again, the surface being worn that's causing a lack of part adhesion. But we can occasionally re-level these. So if you do ever think that your bed is out of level, first, please put in a support ticket. We'll get you to our support center. Put in a ticket with us, and then we can send you a bed level test print to verify if any changes need to be made, and then we can help make adjustments from there. But for making the adjustments after you've had the test print and can confirm that we do need to make adjustments to these points, then what we are doing is the same sort of Z offset check here, but at all of these different points on top of the bed. And then you will go in and adjust these lower portions down here. Each one of these points, there are 12 points across the entire bed platform. Each one of these points is bolted down from the top, and then there are grub screws on either side that push up and thread lock these positions in place. So you have to, if you're making any adjustments to raise or lower the bed, loosen all of these first, and then make the adjustments to either the grub screws or the center screw to raise or lower the bed for each point, and then tighten everything back down, and then that relocks that position. So it's a matter of going in, making adjustments to all the points as needed, and leveling and rechecking the G-code from there. But it is all reliant on the G-code test print that we can provide for you, again, to help relevel these. So if it ever comes in, first step, if you want to check the bed level, is making a support ticket with us. There is no set time frame on it. I typically do not recommend doing it unless you absolutely need to, which again, if it ever comes into question, make a support ticket with us. We can send the G-code, we can verify, and then go from there. But really, you would only ever need to adjust the bed level if you are having severe issues with the parts sticking. The Pro 2s, again, because of the way that we have the whole system locked in place, they typically do not come out of level throughout their lifetime. For the Pro2 series, if you're getting into any kind of carbon fiber materials or anything abrasive, the abrasive materials are going to be anything that has any kind of other particulate that's not just the sort of main plastic. So if it's a carbon fiber, a glass fiber, a Kevlar fiber, any kind of metal fill, stone fill, wood fill is another one that I would recommend, a hardened nozzle, and glow-in-the-dark materials. Glow-in-the-dark materials are actually highly abrasive, so you would definitely need one for those. And then, again, it would just be a matter of swapping out the nozzle tip itself. It will still work with the same hot end, same build surface, but you just want to upgrade to hardened nozzles so that you're not blowing them out as quickly with those abrasive materials. Well, so tips for dual printing settings is going to depend on what exactly you're dual printing. So again, support tickets are the easiest way to reach out to us, and we can kind of help out with settings and fine tunings for most materials. We will prioritize troubleshooting on machines that are running Raise materials because it's easier to troubleshoot. But if we're working with two different duplications, we can kind of work with that. But general tips for most materials, the main thing that you're looking out for is the temperature compatibility of the pair that you're running with. So if you're trying to print a PLA and an ABS, PLA prints with that extruder temperature at 205 and the bed temperature at 60 C. It also typically likes to not be an enclosure, so it have the lid off. ABS prints with the extruders at 250, the bed at 100 C, and the lid on, so it requires a much hotter environment. If you are running PLA and ABS simultaneously, more than likely the bed temperature and the environment required to prevent ABS from warping is going to jam the PLA. So those two materials are almost never going to work together. If you're working with things that are a little bit more in the same temperature range, I've done a little bit with TPU and PVA. Those both do about 220 and use the same bed temperature or something close enough that's not going to affect the entire chamber. Those can be printed together, but that's the main consideration first going into it is temperature ranges for each material. That's going to be it for the stream today. We'll of course save more questions and keep sending them in. We'll answer them later. But I'd like to thank everyone for joining in the stream and stay tuned for what we're going to be doing next.